V1 through Vn and W1 through Wn are linearly independent. Prove or show counterexample that if you take another list where it's obtained by taking each vector and adding them, is this linearly dependent? What do you think? True or false?
False.
Why?
Imagine the lists are the same, but their first two elements are swapped.
That's very good. Yeah. So yeah, false. Just take 1, 0, 0, 1 to be V1, V2, and then 0, 1, 1, 0 to be W1, W2. Then V1 plus W1, V2 plus W2 is just going to be 1, 1, and then 1, 1. Well, they're exactly the same, so they can't be, this list cannot be linearly independent. So that, at first you might think, oh, maybe it's right, but then there's a simple example that it doesn't work. Okay, all right, so for this second one, if V1 through Vn is linearly independent, and then there's some vector W where if you add them, somehow this becomes linearly dependent. Okay. If this happens, show that W is in the span of V1 through Vn. Okay. All right. So at first, this sounds pretty hard, but just start writing down what you know. So what does it mean to be linearly dependent? That means there exists A1 through AN such that A1 times the first vector V1 plus W all the way up to AN times the last vector Vn plus W is equal to 0 with not all or with some ANs non-zero, okay? With some ANs non-zero. Okay. That's what it means. That's what linear dependence means. So we just write down the definition. And then I still don't know what to do, but I mean, there's a way to simplify this. So let's try to reorganize this. You can rewrite this as A1 V1, AN Vn, and then A1 times W, A2 times W, all the way up to AN times W. We can put them together like this. Okay. And then look at this. Does this have anything to do with W being in the span? I think so, because you can move everything on the right side and divide by this, then you've shown that W is in the span, right? So noticing that is a way to solve this problem. However, the only thing is, what if you divide by 0? That's not allowed, right? So that has to be handled separately. So case when A1 through AN equals to 0, okay? Then we have, if this is 0, then this is simply 0, right? But if this is 0, then
it's linearly independent.
Because V1 through Vn is linearly independent, then every one of this is 0. Which is a contradiction because we have some ANs non-zero, right? So, so this can't happen. Okay. So case A1 plus AN non-zero. If it's non-zero, we can happily rewrite that as W equals to negative A1 over A1 plus da 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 AN V1 plus all the way up till the last one, negative an over a1 plus da 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 an vn, which obviously is in the span of v1 through vn. Right. So, so the real lesson here is that even if something looks hard and cryptic, just write down the definition, see what it means, and start from there. And sometimes it just works out. Okay.